Now I will unbox the Mimic FT Tracker. Inside the box you will find a quick start guide, which will tell you a little bit about the FT Tracker, an overview of Mimic in general, how to install the UR cap, how to set up the hardware, and lastly an overview of the components in the box. Underneath the quick start guide we have a USB pin with the software. We have an encryption key with the license. We have the FT Tracker itself, the Mimic control box, an angle bracket to mount the FT sensor on the robot, and different screws and vibration dampeners to mount the FT Tracker on the robot. Underneath we have a 3-pole power cable to power the Mimic control box. We have a 4-pole connection cable between the FT Tracker and the Mimic control box. And we have an Ethernet cable between the Mimic control box and the robot controller. Now we will mount the vibration dampeners on the FT sensor. And next we will mount the FT sensor on the ankle bracket. Alright, first we put on the vibration dampeners. Then we put the FT Tracker on the ankle bracket. Now we will mount the FT Tracker and ankle bracket on the robot flange. Now we will connect the FT Tracker with the Mimic control box using the 4-pole cable. Then we will connect the Mimic control box with the robot controller using the Ethernet cable. First we connect the FT Tracker to the Mimic control box using the 4-pole cable. Be careful when connecting the 4-pole cable. Make sure you turn the cable until it slides in. You don't need to apply an excessive amount of force, then you can break the pins. Same goes on the other side, on the Mimic control box. The 4 poles, we turn the cable around until it slides in, or not. We turn it around until it slides in, and fasten the screw. Then we connect the Mimic control box to the robot controller using the Ethernet cable. Alright, then we move down to the control box. We connect the Mimic control box to the robot control box by plugging in the Ethernet cable to the robot control box. Now we will connect the power cable for the Mimic controller to the robot control box. Now we'll wire the power cable for the Mimic control box. We will wire the red to 24 volts in the control box. We can use any 24 volts. In this instance, I use 24 volts from digital inputs. Same for the black wire and 0 volts. We can use any 0 volts in the control box. In this instance, I will use the 0 volts from a digital output block. Then we connect the 3-pole connector on the power cable to the 3-pole connector on the Mimic control box. Again, we turn around the connector until it slides in. No need to exert extra force. The blue encryption key holding the license always needs to be inserted into the robot control box. To install the software, to install the Mimic UR cap, we insert the accompanying USB flash drive into the Teach pendant. We go to Settings, System, and UR caps. Then we hit the plus icon. Then we enter the USB disk and select the Mimic UR cap. We open the Mimic UR cap, wait a couple of seconds for it to appear in the list, and then hit restart. Now we will apply the needed settings for the Mimic UR cap. First we go to Settings, to System and Network. In the network settings, we need to apply a static IP address. And this IP address we will set to 192.168.0.99. Hit OK. Then we need to set the subnet mask, and we will set this to 255.255.255.0. Hit OK and hit Apply. After a couple of seconds, you should get a green check mark saying network is connected. Now we will enable Mimic and configure the FT Tracker. We will head to the Installation tab, go down to UR caps and find Nordbo Mimic. In here we will land on the Get Started page, where we need to check the box to enable Nordbo Robotics Mimic. Then we head to the Configure tab, select the FT Tracker and hit the button underneath to select the FT Tracker as the currently used tracker. On the right side, we should now have a green check mark showing that we have a successful connection to the FT kit. Before we start calibration of the Mimic parts, it's important that you calibrate the TCP on your robot. To do that, you go to Installation, General, and TCP configuration. If you need any help configuring your TCP, you can find more information on the Universal Robots Academy. Now we will calibrate the FT Tracker orientation in relation to the robot. We will go to Installation, to UR caps and Nordbo Mimic. Here we will go to Configure, to Trackers and FT Tracker. On the bottom of the FT Tracker page, we find Calibrate Tracker. If we click that, we need to turn the FT Tracker such that the axis of the FT Tracker align with the axis of the robot base. We can see denoted y-axis on the FT sensor points in the same direction as the robot, the wire coming out of the robot base, which then means that the y-axis are aligned. And by pointing the FT Tracker straight up in the air, we also align the z-axis with the robot base z-axis. When we have two axes aligned, the third axis will also be aligned. We can then hit OK, and Mimic will automatically calibrate the orientation between the FT Tracker and the robot. Hit Save to confirm. We go to the Program tab. On the left side, under UR caps, you will find 4 new nodes: Mimic, Play, Teach, Track, and Tune. We start by adding Mimic Track. In the Command tab of the Track node, we will need to set up a couple of things. In the text field next to name, we need to put in a name for the recording. I will call my recording test 1. In the robot TCP dropdown, we select the TCP that we have calibrated. In the joystick dropdown, the FT standard joystick should already be selected. And the conveyor dropdown, we will leave on no conveyor. Last, we can expand features. Next, we add the Mimic Tune node. In the Command tab of the Tune node, the Track radio button should already be selected. In the trajectory dropdown, we select the recording, in this case test 1. In the robot TCP dropdown, we select the TCP that we calibrated. The joystick dropdown should already be on FT standard. We will leave the set outputs toggle off, and then we can expand features. Finally, we add the third step, the Mimic Play node. In the Command tab of the Play node, the Track radio button should already be selected. In the trajectory dropdown, we select our recording, in this case test 1. In the robot TCP dropdown, we select the TCP that we calibrated. We will leave the conveyor dropdown on no conveyor and set outputs toggled off. Now we have set up a simple Mimic program with track, tune, and play, and we will start recording motions. First, we need to start the robot program. To do that, we hit the Run button. Then we make sure that the track node is selected. And once the Move button in the track node becomes active, we can hold down the Move button and drag around the robot using the FT Tracker joystick. Now we will record a straight line. To do that, click the Record button, then hold down the Move button and drag the robot in a straight line. Release the FT joystick, release the Move button, and click the Record button once again to finalize the recording. Next, we will continue to the Tune node. Before we do that, be aware that the robot will move to the first point in the recording. To continue, we hit the button in the top right corner of the track node. The robot has now moved to the first point in the recording. Make sure to select the Tune node. In the Tune node, we can use the Forwards button to move forward in the recording. And we can use the Backwards button to move backwards in the recording. The idea is that we go through the recording until we find any errors in our path. To correct this error, we can hold down the Move button and move the robot a distance down. Then we can use the Backwards button to see how this affects our path. We can see that there is a slow slope down to the new offset, and we can see that this offset persists for the rest of the recording. We forward all the way to the end of the recording, and now we want to continue to the play node and see the final results. Again, be aware that the robot will start moving. To continue, we hit the continue button in the top right corner of the tune node. And to follow along, make sure the play node is selected. Now we run through the features you can use to get more control over the robot motions and your recording. First, we start the robot program by hitting the Run button. Make sure that the track node is selected and wait for the Move and Record buttons to become active. The first button in the top left corner, Align Robot Orientation, is disabled because it is not used for the FT Tracker. Below that, we have Scale Joystick Movements by. This text field you can use to make more accurate motions by scaling down. And for this example, I will scale down to 0.2 and hit OK. Now, when we hold down the Move button and drag the robot by the joystick, you will feel that it requires more force to move the robot. This allows for easier, small, and accurate motions. On the other hand, you can use the text field to make faster motions. This can be done by scaling up. In this example, I will scale up to ×2 and hit OK. And now we hold down the Move button. It requires a lot less force to move around the robot, which makes it easier to make fast and large motions. On the right side of the track node, you can see 6 toggles, one for each of the positional axes, X, Y, and Z, and one for each of the rotational axes, RX, RY, and RZ. If we lock all of the positional axes, we're now able to adjust the angle of the robot without adjusting the position. So by holding down the Move button, you can now adjust the robot at an angle. If instead we unlock all of the positional axes and lock all of the rotational axes, we can move around the robot and ensure that we always keep the same angle. Now let's make an example where we want to keep the same height towards this table at all times, and we also want to keep the same angle towards the table. To do this, first we can disable the Z axis. Now when we move around the robot, we keep the same height to the table. Then by locking each of the orientational axes, RX, RY, and RZ, we can ensure that we keep the same angle towards the table at all times. And now I can move around the robot without thinking about keeping the correct angle and the correct height towards the table. Now we will use the features that we just saw to record a more accurate straight line. First, we will scale the joystick movements down by 0.5 and hit OK for more accuracy. Then we will log the Y and the Z axis to make sure that the robot can only move in one straight line. We will also log all of the orientational axes to make sure that we keep the same angle. Then we hit the record button once to start recording. Hold down the move button, and we can effortlessly move the robot in a straight line. Release the joystick, release the move button, hit the record button once again to stop the recording. Next, we will move on to the tune node. Remember that when we hit continue, the robot will move to the first point in the recording. Hit the continue button in the top right corner of the track node. Okay. Make sure that the tune node is selected. In the tune node, you see the same features to scale joystick movements and to log each of the positional and the orientational axes. These can be used to make more accurate corrections. We will forward a bit to see how the wide local correction works. In the correction interval dropdown, select wide local. Then hold down the move button and make a correction downwards. Then use the backwards and forwards buttons to go over this wide local correction and see how the robot moves slowly down towards the correction and then slowly back to the original recording. Let's forward a little bit more to see how a local correction affects the path. In the correction interval dropdown, select local. Hold down the move button and make another adjustment downwards. Use the backwards and forwards buttons to see how this correction affects the recording. We can see how the robot moves fast down to the correction and then fast up to the original recording. Forwarding a little bit more, let's apply a global correction. So in the correction interval dropdown, hit global, then hold down the move button, move the robot down. Use the backwards and forward buttons to see how the robot moves slowly to the correction and keeps this correction for the rest of the path. Let's continue to the play node and see the full recording. Hit the continue button in the top right corner and the robot will start moving. Going back to the tune node, on the left side, select the speed tab. Here we will see the override robot speed text field. In this text field, we can select a speed to override different sections of the recording with. Right now, I will select 80 millimeters per second and hit OK. And let's forward into the recording just before our wide local offset. Now toggle on the override robot speed on the right side and forward over a section. I will forward past the wide local correction and toggle off the override robot speed. We will now see a marking on the progress bar showing that we have a constant speed past the wide local correction. We will not be able to backwards and forwards over the section to see the applied speed. We will only see the applied speed when actually playing the recording. Let's go past the overwritten speed and select a different speed to override a different section of the recording. For now, I will select 20 millimeters per second, toggle on the robot speed override, and forward past the local correction and the global correction, and then toggle off override robot speed again. Forward through the full recording, and then we can hit continue in the top right corner to see the result. Be aware that the robot will move. So we see how the robot goes relatively fast here, and now it goes much slower with the 20 millimeters per second. We can also see that this very fast motion down to the local offset now becomes much slower. And back in the tune node, on the left side, we can go to the output tab. In the output tab, we can override the state of the digital outputs in the robot control box and also in the tool output. It works kind of the same way that we override the robot speed. We can forward in the recording. Then we can toggle override outputs, and then we can toggle on any output that we want to turn on. Let's say, for example, I had a tool hooked up to digital out 0. I will enable digital out 0. I will forward throughout my recording, and when I want to stop the tool again, I will toggle off the override of outputs and go to the end of the recording. Now let's hit the continue button in the top right corner to see the result of the tuning. If we go to the I/O tab, we can see how digital out 0 is not turned on. This is because the set outputs toggle in the play node is toggled off. The reason for this toggle is that you can make a dry run where you see just the path without actually turning on the tool. If we go back to the program tab, stop the robot program, go to the play node, the command tab in the play node, and toggle on set outputs. Now we can play this by hitting the run button and select play from the play node. This time we will see how the robot moves, and if we go to the I/O tab, we will see how digital out 0 is turned on, and at the end of the recording it will be turned off again. Now we will create a simple production program simulating an operator placing a new workpiece in front of the robot and signaling the robot to start working. For the production program, I have wired up a button to digital out 3 that we can use to signal the robot when it can start working. Let's go and create a new program. First, we will add a waypoint. In a position where the robot can wait for a new piece. Select the waypoint and set the position. After this move, we will add a wait. And we will wait for digital in 3, which corresponds to my physical button. We will wait for digital in 3 to go high. When that happens, we will insert the Mimic play node. In the command tab of the play node, the track radio button should be chosen by default. In the trajectory dropdown, we will select test 1, the recording we have made throughout this webinar. In the Robot TCP dropdown, we pick the Robot TCP. We leave the conveyor dropdown on no conveyor, and we toggle on set outputs. Now, when we run this program, run from beginning, the robot will be in the waiting position. It's waiting for the operator to place a workpiece in front of the robot and signal the robot to start working. The robot will go down and play the recording on the workpiece. And once the robot is done, it will go back up into the waiting position. The operator can then remove the workpiece and place a new workpiece in front of the robot. Again, signaling the robot to start working. So this way you can build robot programs. You can build robot programs with logic. You can build robot programs using the nodes that you are used to building programs with on a UR robot. And then you can just let Mimic take care of the complex motions.